5 is methods of combining functions. There are 5 ways to combine functions. The first 4 look something like this. You could add functions together. You could subtract them. You could multiply them. And you could also divide them. And the way to add, subtract, multiply, and divide is to do exactly what you think you would do, which is to take f of x and add it with g of x, or f of x minus g of x, f of x times g of x, or f of x over g of x. Yes?
Is the fifth one like the f of g?
Yes. 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 We'll get there in a minute. Now, a very important point here is that the domains... Oh, hold on, one more thing here. G of x can never equal what here? Okay, good. So that's something we need to look out for. The domains of these combinations are the intersections of both domains. So, for example, if the domain for f looked something like 0 to infinity, bless you, and the domain for g looked something like all real numbers, yes. So like if you think of a number line, you graph both domains on a number line to see what's going on. Closed looks like that. For the first one, this is for f. And then for g, if it's the entire number line, then it looks like that. So where's the intersection? Where do they overlap? 0 to infinity. So that's what I mean by the intersections of both domains. Okay?
So they both are like...
Yes.
What if there's no intersection?
Then, well, you wouldn't have that. Because then you wouldn't be able to add, yeah. There will be. That's a good question, but generally you're always going to have some kind of intersection there. Okay? So, let's do one example. We'll do all 4. We'll go through the domains, and then we'll go to the 5th one. So I don't really want to do tons of examples because I want you guys to work through this. Let's say f of x equals x plus 9. And let's say g of x equals x squared minus 4x. Okay? Currently, let's write the domains for both, just so we know what we're working with here. What's the domain for x plus 9? Good. What about this quadratic? Also all real numbers. So it looks like we're not going to have any issues with domain at all unless maybe we're dividing. So we'll deal with the division when we get there. Okay? So let's do f plus g of x. F plus g of x is going to be f of x plus g of x, which is x plus 9 plus x squared minus 4x. Can we combine anything? The 4x and the x, so it's x squared and how many x's? Careful. It's x and then negative 4x. Negative 3x, good, and then plus 9. So this is f plus g. F minus g, and this is why I use parentheses, guys. Always use parentheses. Is going to be what? X plus 9 minus the quantity. Yep. So if it helps you to distribute the negative first and then combine like terms, do that. Otherwise, you can just do it. X squared is going to be negative. X, and then how many x's here? X plus 4 is 5, and then we still have the plus 9. Okay. F times g is exactly f of x times g of x. So x plus 9 times x squared minus 4x. And how do we multiply that? Yeah, good. So x times x squared is x cubed. So, kind of go slow because we're not used to doing these weird square quadratics with x plus 9. X times negative 4x is minus 4x squared. Distribute the 9, so now it's 9x squared. And then last term is minus 36x. So then the final answer is x cubed plus 5x squared minus 36x. Okay? All three of these, the domains are all real numbers because we're not dividing them. When you multiply, add, or subtract them, the domains are whatever the domains are for both of them combined. Yes?
For dividing, is it always going to be f over g, or can it ever be g?
It could be g over f. Yeah. That's a good question. And then you would just pay attention to whatever's on the denominator. All right, so let's say I have f divided by g of x. What's in the numerator? So x plus 9 over x squared minus 4x. And you can leave your answer like that. That's fine. There's not really much else to do because I don't think anything's going to cancel. However, if I ask you for the domain, this is the one that's a little different. All these other ones were all real numbers, but the only issue with this is we can never what? What can never equal 0? So let's figure that out. X squared minus 4x can never equal 0. That's good. So how do I solve there? X times x minus 4 cannot equal 0. So that means x cannot equal 0 or what else? Or 4. So you could either write it as x not equal to 0 or 4, or if you want to do interval notation, let's...
So is the answer for f divided by g of x going to be x
This.
guy?
Yes, that's the answer.
Okay, so then
But now,
if it asks you for domain...
if it asks you for the domain, then you'd have to do this to figure it out.
Okay.
Yep. Do you guys know how to do this in interval notation?
Yeah.
Okay.
Wait.
No? Draw a number line if you're confused. Put an open circle at 0 and 4. How many intervals should there be?
3.
What are they? Wow, you guys are awesome today.
Wait,
Good
why
job,
is
Saeed.
why?
Negative infinity to 0, 0 to 4, and then 4 to infinity are the three intervals. If these are the only two numbers that don't work, right? Okay. Any questions on the first half? Okay. Compositions. That's the last part. So compositions look like this. F, it looks like it says fog, okay? Or sometimes like this, and it looks like it says Goff, okay? But this is actually how you read them. This means the exact same thing as f of g of x. And this would be the same as g of f of x. Okay, and some people get confused with these, and they can be a little tricky, but I'm going to try to make things as easy as possible. And if you have your calculators handy, take them out for one of these problems, because I want to make a big point of one of the domains here. Okay. So let's do an example. Let's start with f of x equals x squared plus 5, and g of x equals the square root of x minus 9. when you're doing compositions, check domain after first step. That's the only thing that changes here. So these domains may be all real numbers for this one, and then a little bit. What is the domain here, by the way? X minus 9 has to be greater than or equal to 0. So if we solve it, 9 to infinity. Does that make sense? This is all good. So these are the domains for each one of them. But things could change a little bit depending on what you're doing with the composition. So check for the domain after the first step. Okay? If they want domain, sometimes you don't need it, you just do it. That's the easy question. Other times they'll ask you to find a composition and then also write out the domain. So let's do that. Let's find f of g of x, which is the same as fog. Okay? So this means you take g and you plug all of the g function into the x of f. Does everybody understand? So now f of x, or I'm sorry, let's actually go one step at a time. What is g of x? G of x is the square root of x minus 9. So that is what we're going to plug in to the f function. So what's the next step going to say?
Square root of x minus 9 squared.
And then we still have the plus 5. So here's what I mean right here. Check for domain right away after you plug it in. Because when you simplify stuff, it may look like it's a really nice equation and everything's good and everybody's happy. But it's not really. And this is why I want you to have your calculator so I can show you and convince you that this is what you must do. Before I square it, I have to do the square root of x minus 9. Agreed? So right now, if I were to say the domain for this, I'd start by saying that x minus 9 has to be greater than or equal to 0, like we did earlier. So x has to be greater than or equal to 9. Does that make sense? Because of the square root. Now, if I simplify this, what happens when I square it? It's just x minus 9 plus 5, which equals x minus 4. This is essentially the answer, but only when we're talking about numbers that are 9 or more. So if you make the mistake of saying, well, here's my answer, it's a line. My domain is just all real numbers, right? It's not quite the same. Okay, so here's what I'd like for you. Can I borrow somebody's calculator? Perfect. So just so you can see how this works, go to y equals. Okay? Type in, I'm going to use y1 as f, and I'm going to use y2 as g. So for y1, I'm going to type in whatever f was. What was f? X squared plus 5. Oop. And then for y2, I'm going to plug in the square root of x minus 9. Okay. So now here's what I'd like for you to do. Go up to the equal sign in y1, turn it off. Turn it off for y2. You know how to turn it off? You just hit enter on the equal. So now what's going to happen, if I graph, these aren't going to show up. What we want to graph, what was y1? Y1 was really f, right? And y2 was g. How do I write that if I'm looking at f of g of x? How do I write that in the calculator?
Use parentheses.
What's f? So this is the same as y1 of y2 of x. So we can tell the calculator to do the composition for us to see what it looks like. Okay? So what I'm going to do now is for y3, if you go to, I'm trying to remember, vars. Yep. Where is it? There it is. If you go to vars, right here, the vars button, you go to y vars. The first option says function. Hit enter. And now this is where you can tell your calculator to look at y1 or look at y2. So I'm going to hit enter and see how it puts y1 in there now. So now what do I hit next? Parentheses. Yes, now we go vars, y vars, function, and now we want y2 of x. So if you type this in, you're telling your calculator to do the composition that we just figured out. Does everybody understand that? Let's hit graph. You got an error?
Yes.
Did you type in everything exactly the same?
I just have a little line on
Yes, you should have just a little thing at the end. And here's why we have the little thing. What did we say the domain was for this composition?
Greater than 0.
What'd you get in bars?
Or 9.
We had 9 or more, right? So what this graph is doing and you know what? Here, for y4, let's type in our answer so we can compare. X minus 4. Okay? So this is f, this was g. y3 is now written as f of g of x. And then this is my final answer that we got, right? If we hit enter on the equals for y3, now it's just going to graph x minus 4, right? That's what we thought the answer was. However, if you graph just y3, what's the difference?
only goes short of line.
It only gives you the part that's what?
Greater than 9.
Greater than 9. Okay? If you look at your tables,
People have the error
ooh. If you hit enter on all the equal signs, so you can look at the tables, this is kind of interesting. So now all 4 of them, right? Go to table. You can start to see where the issues come up. Okay? Which is kind of nice to compare all the different functions in one spot. Okay? Are there any questions? I mean, you don't really have to know how to do this in the calculator. It doesn't hurt. It's kind of a neat thing to be able to figure out.
What's the final answer?
The final answer. Okay. It didn't work? All right, we'll look at it in a little bit. Okay? The final answer, if it says to find f of g of x, you'd say it's x minus 4. Now, if it asks you for the domain, you would say the domain is from 9 to infinity. That's it. Okay? You can do it both ways. We don't need to go that direction. Okay. Now, finding composite values is actually very easy. So sticking with the same examples, okay? If I ask you to find, let's say, f of g of 13, okay? Bless you. If I ask you to find f of g of 13, you have 2 ways of doing this, assuming that we're using the same graph. So f of x equals x squared plus 5, and g of x was square root of x minus 9. Okay, one option. First you find f of g of x, which we already did, right? What was it? X minus 4. And now you just plug in f of g of 13. So this would be 13 minus 4, which is 9. Okay?
Can you just plug in 13 to the...
That's the other option. Okay, so there's 2 options. If you already have the function that you figured out, f of g of x is x minus 4, and you want to know what f of g of 13 is, you can just plug 13 into your composite function. Okay, the other option, which I think is also pretty easy, is to go one step at a time. So if you have f of g of 13, first, can we figure out what g of 13 is?
Yeah.
That just means take 13, plug it in, right?
Yes.
So it's the square root of 13 minus 9. 13 minus 9 is 4. The square root of 4 is 2. So f of g of 13 is really just finding f of 2. Can we find f of 2? 4 plus 5? It's 9. So either way you do it, you still get the same answer. It is. It's really just, this is all just substitution and simplifying. Okay? Last topic, and this is not very long. So the objectives on the board. Think about what we've done so far. Evaluate sum, difference, products, quotients of functions. You guys can do that, right? Evaluate compositions. That's what we just went over. You guys good with that? The last one is to determine if functions are even or odd. Okay, so what I'm going to do is first tell you the definition of even and odd, and then I'll show you a very easy example. Even. Two functions are even if f of negative x equals f of x. In other words, plugging in negative x or just regular x doesn't change the function. Where have we seen that before? Plugging in negative x and it's the same.
Absolutely.
That's an example of one. A squared function, yep.
Even.
Well, absolute is not even, but...
Zero.
What about symmetry, guys? Where have we seen something about symmetry where you plug in negative x and it's still the same function?
Zero.
There you go. This is very much the same as y-axis symmetry. Okay? So if you remembered y-axis symmetry, you can determine if something is even just by looking at the graph again. Algebraically, oh, this doesn't make sense. No one said anything. Two functions if. Two functions are even. I said it. I didn't write it. Sorry about that.
You're nervous because it's you and I do too.
I'm so nervous. So, odd. Same idea. Two functions are odd if, when you plug in negative x, you don't get f of x, but you get the opposite of f of x. Okay, so these are the definitions for even and odd. And here's how you work with them. Okay, so if I give you an example, f of x equals 9 minus 4x squared, and I say, show if even or odd. All you do, every time, first, you figure out what f of negative x is. Because you see, both definitions involve figuring out f of negative x, right? So first thing you do, you figure it out. So 9 minus, if I plug in negative x and square it, what do I end up with? 9 minus 4x squared. 9 minus 4x squared, is that the same as f of x?
Wait, why are you keeping the square?
What do you mean 9 minus 4? Wouldn't it be plus 4x?
No, because first you square the negative, so that's x squared, and the negative 4 is still there.
So why do you keep the negative, or the square, if you already squared it?
Well, because it's a variable. It's not like a number where I can square it and say it's 7 now. So since it's x, we have to leave it as x squared. Okay? So what happened here? Did we get anything different? We got exactly what? So when I figured out f of negative x, I got 9 minus 4x squared, and look, that was the same as the original function. So what is this? Even. This is easy stuff. Okay? Let's say g of x equals x cubed plus 5x. And I ask you the same question. Let's start. First, we calculate what?
It's odd.
Shh, don't tell the secret yet.
It's cubed.
First, you plug in
Negative.
negative x and see what happens, right? So you do negative x quantity cubed plus 5 times negative x. What happens when I cube a negative? It's negative x cubed. A positive times a negative here is minus 5x. So I'm going to stop here and say, is this the same as g of x?
Yes.
No. Goofballs. Yes, that's this. No, it's not. What can I factor out? A negative. And then what happens? X cubed plus 5x. And now this is the same as g of x. Does that make sense?
Mr. Gonzalez, do your YouTube fans know what you look like?
Yes, there's a
Yes.
picture on my YouTube channel of me.
Oh.
With his
But they don't know
glasses.
how I look like.
Yeah, he looks like a beast.
Thank God.
My God. Okay, guys.